Welcome students to online classes of mathematics for class 8. In this video we are going to study the chapter number 3, which is understanding quadrilaterals, and we'll try to cover the exercise 3.3. This is the session number 4 for this particular chapter. Myself Deepak Gautam, teacher mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The chapter that we are studying today is understanding quadrilateral. This chapter is divided into total 5 subtopics, out of which we have already covered the first 3 subtopics in the previous sessions. Okay, now today we are going to start with the fourth subtopic, which is kinds of quadrilateral. Okay, so let's start. So first we have kinds of quadrilateral. So there are total 7 types of quadrilateral. There are total 7 types of quadrilateral, which are: first one is a trapezium. Then we have a special case of a trapezium, which is known as the isosceles trapezium. Then we have kite, and then we have parallelogram, and these are the 3 special type of parallelogram. These are special parallelogram, okay, which are rhombus, rectangle and square. So we'll study one by one their definition and their properties. Okay, so let's start with the trapezium. Before that, we have this family of quadrilateral, or you can say quadrilateral family. So first we have here quadrilateral. This is the general shape of a quadrilateral, or a figure of a quadrilateral. So there are majorly 3 types of quadrilateral. First one is a trapezium, second we have kite, and third is the parallelogram. Okay, in trapezium we have another special type of trapezium, which is known as isosceles trapezium. Then in parallelogram there are 3 types of special parallelogram. First one is known as rhombus, then rectangle, and the third one is a square. Okay, we'll study all of them one by one, their definition and the properties. Okay, so let's come to the first one, which is a trapezium. The definition of trapezium is a flat shape with 4 straight sides, in which one pair of opposite side is being parallel and the other pair is not parallel. So the main thing in the trapezium is, when we have this a general quadrilateral, like this is a general quadrilateral, if any of the 2 sides of this quadrilateral, let's say these 2, if these are parallel, then this will be known as trapezium. Okay, that's what the definition says: a flat shape with 4 straight sides. That means the side should be straight, in which one pair, this is the most important part of this definition, that one pair of opposite side being parallel. That means one pair of opposite side has to be parallel. Suppose this is, let's give it name A, B, C and D. Here in this one, these opposite side AB and DC are parallel. That means this AB is parallel to DC, hence ABCD is a trapezium. Okay, then we have this isosceles trapezium, which is a special type of trapezium. It says if the non-parallel sides of a trapezium are of equal length, then it is called isosceles trapezium, which means, suppose if these 2 sides are parallel, then these 2 are the non-parallel side. If their measurement is equal, that means if the non-parallel sides are equal, then that trapezium is called isosceles trapezium. Okay, so if the non-parallel side of a trapezium are equal in length, then it will be termed as isosceles trapezium. Okay, I hope it's clear to you. So first we have a general quadrilateral. If any of the 2 opposite side is parallel, then it will be called trapezium. And in trapezium, if its non-parallel sides are equal in length, then it will be called isosceles trapezium. Okay, then we have kite. Not kite, first we'll look at the properties of the trapezium, which are: one pair of opposite side is parallel. So in a trapezium there should be a one pair of opposite side parallel, like in this case these 2 sides are parallel. The second property of trapezium is 2 pair of adjacent angle add up to 180 degree. When you take the pair of adjacent angle, suppose these 2 angle and these 2 angle, so their sum has to be equal. Let's name it A B, C and D. The second property says the pair of adjacent angle add up to 180 degree. That means the angle A plus angle D will be equals to 180 degrees. Similarly, angle B plus angle C will also be equals to 180 degree. Okay, so these are the adjacent angle which are sum up to 180 degree, but not this D or C will be equals to 180 degree. Similarly, this A and B will not be equals to 180 degree, but this pair of adjacent angle, in this case AD and BC, are their sum add up to 180 degree. Okay, then we have the third property, which is diagonals bisect each other. That means when you draw the diagonals of this trapezium, they will bisect each other. Okay, moving ahead to the next type of quadrilateral, we have now kite. This is a general shape of a kite. The definition says kite is a type of quadrilateral with two pairs of equal consecutive side. With two pair of equal consecutive side, like you can see in this one, this side EF and GF are of equal measure. Similarly, this ED and GD are also of equal measure. So it has two pair of consecutive side. Consecutive means the side which is followed by one after the other. Okay, so consecutive side, so its consecutive side is either this one or this one. These two are not equal, but its next consecutive side, this FG, is equal. That means this EF is equals to FG. Similarly, ED is equals to DG. Okay, so these are the pair of side in this kite which are equal in length. So if in any quadrilateral, if you have two pair of consecutive side which are of equal length, it will be termed as a kite. So here are the properties of kite. The first one is that diagonals are perpendicular to one another. So when you draw the diagonal means when you draw the line segment joining the non-adjacent vertices of a quadrilateral. That means suppose we have a quadrilateral like this. If we join its non-adjacent vertices, so for this vertex, its non-adjacent vertex is this one. So when you join this, and similarly for this, its non-adjacent vertex is this one. So when you join these two lines, they will be called as diagonal. So it says the diagonals are perpendicular to one another. So similarly, when you in a kite, when you draw this diagonal, they will intersect each other at the right angle. That means an angle here will be 90 degrees. Similarly, this will be 90 degree here, and also 90 degree here. Okay. Second one is one of the diagonal bisect the other. So one diagonal will bisect the other. It's E here. The one of the diagonals bisect the other. So in out of the two diagonal, one diagonal will bisect the other. See, you can see in this figure, the diagonal, this diagonal DF is bisecting EG. So this EH is equals to HG here. Okay, that's the second property. That's what the second property says. The third one is one pair of opposite angle is equal. In the kite, you will always find that one pair of opposite angle is equal. For this example, the angle E is equals to angle G. These two angles are equal. Okay, so these are the properties of kite. So basically in kite, there will be two pair of consecutive side which will be equal in length. Second property, diagonal will bisect each other perpendicularly. Not bisect, diagonal will intersect each other perpendicularly. And the third and the last one is the one pair of opposite angle will be of equal measurement. Okay, these are the properties of a kite and the definition. Moving ahead to the next one, which is a parallelogram. This is the most important part of this chapter, parallelogram. Okay, the definition of parallelogram says parallelogram is a quadrilateral whose each pair of opposite side is equal and parallel. Okay, the parallelogram is a quadrilateral whose each pair of opposite side is equal and parallel. That means each pair of opposite side is equal. That means this AD is equals to BC. Similarly, this AB is equals to DC. Also, this side BC is parallel to AD. Similarly, AB is parallel to CD. Okay, that's what the definition of parallelogram says. Parallelogram is a quadrilateral whose each pair of opposite side is equal and parallel. Okay, so if in any quadrilateral you find the opposite sides are equal and parallel, then it will be called as parallelogram. So now we have the properties of parallelogram. So the first one is opposite sides of a parallelogram are of equal length. That means opposite side of parallelogram are of equal length. Second is opposite angle of a parallelogram are of equal measure. That means opposite angle, the angle opposite to A will be angle C. That means angle A will be equals to angle C. Similarly, angle B will be equals to angle D. Okay, angle B will be equals to angle D. Okay, in this one opposite sides are parallel, so I'll write AB is equals to DC and AD is equals to BC. Okay, next is adjacent angle of a parallelogram are supplementary. This supplementary means their sum will be equals to 180 degree. Okay, that means the sum of the adjacent angle is 180 degree. That means the adjacent angle of A is either B or either D. So if you add A plus B or A plus D, you will find their sum as equals to 180 degree. That is angle A, let's write plus angle B will be equals to 180 degree. Similarly, angle B plus angle C will be equals to 180 degree. Also, angle C plus angle D will be equals to 180 degree, and angle D plus angle A will be equals to 180 degree. Okay, so the each pair of adjacent angle will sum up to 180 degree. That means they are supplementary. Okay, next is the diagonals of a parallelogram bisect each other. So when you draw the diagonal of the parallelogram, they will bisect each other, not perpendicularly, but they will bisect each other. That means this part of the diagonal will be equals to this part. Similarly, this part of the diagonal will be equals to this part here. Okay, that's the property of the parallelogram. So now we have discussed all types of quadrilateral. We have total 7 types of quadrilateral. Okay, we will study about these 3 in the next exercise, but not here. Okay, till now we will only discuss the till parallelogram. These special parallelogram will be discussed in the next class. Okay, now based on these 4, we have the exercise 3.3, and before that we have few examples. So let's first solve the examples. So this is our chapter number 3, understanding quadrilateral, or in which we are doing kinds of quadrilateral. Okay, the first example that we have here is find the perimeter of parallelogram PQRS. Okay, we are asked to find the perimeter of parallelogram PQRS, which is given here, in which PQ is given, which is 12, and QR is given as 7 centimeter. Okay, now from the properties of parallelogram, we know that in parallelogram opposite sides are equal in length. So I'll write a solution of example 3. So as we know, in a parallelogram PQRS, okay, the side PQ will be equals to the side. So when you write this as PQ, so we're writing this end first, P and Q, so its opposite side will be SR, not RS. Okay, so we'll write its opposite side SR. I'm writing side, not the angle. Okay, so PQ will be equals to SR, and that will be equals to, as PQ is given, which is 12 centimeter. So you have to write the region here. Region here is opposite sides of parallelogram are equal in length. Opposite sides of parallelogram, this is a symbol for parallelogram, are equal. So we'll write this region, opposite sides of parallelogram are equal. That's why PQ is equals to SR. And then we write similarly, side QR will be equals to PS. This side QR will be equals to side PS. That will be equals to 7 centimeter. And the region for this is again same. That is opposite side of a parallelogram are equal. Therefore, now we got the measurement of all four sides of this parallelogram PQRS. Now we can find its perimeter. So write hence the perimeter of parallelogram PQRS is equals to PQ plus QR plus SR plus PS. So the PQ is 12, QR is 7, SR is again 12, and PS is 7 centimeter. So when you add all this number, you will get 12 plus 7 is 19, again 12 plus 7 is 19, and 19 and 19 is 38 centimeter. Is 38 centimeter. So that's the solution of the example number 3. We are asked to find the perimeter of this parallelogram. So we have got its perimeter as 38 centimeter. Okay. Now moving to the next example, we have example number 4. This question is, in figure 3.26, best is a parallelogram. Find the value of x, y, and z. We are given the three angles here, x, y, and z, and we are asked to find the measurement of all these three angles. Okay. So let's start the solution. So in a parallelogram, we know that opposite angles are equal. So the angle, this angle B will be equals to angle S. As the measurement of angle B is 100, so the value of x will be 100. So right, in parallelogram, which parallelogram? We have the parallelogram BEST, best, BEST. In parallelogram BEST, best, then comma, then we'll write angle B will be equals to angle S. And as we know, or angle B is equals to angle S, therefore angle S will be equals to 100 degree. Region for this one is opposite angles of parallelogram are equal. Opposite angles of a parallelogram are equal. Okay, that's why the measurement of angle S is equals to 100 degree, or S is given as x. So at the place of x we can write, or x is equals to 100 degree. Then we have to find the angle x, y, and z. So we have study another property of parallelogram, which says the adjacent angle of a parallelogram are supplementary. So the adjacent angle of this angle B is angle E. So we'll write also angle B plus angle E will be equals to 180 degree. Region for this one is adjacent angles of parallelogram are supplementary. Okay, are supplementary. As we already know the value of angle B, which is 100 degree, and angle E is angle Z equals to 180, or Z will be equals to 180 degree minus 100 equals to 80 degree. Hence this value of Z will be equals to 80 degree. Okay, then we have to find the value of angle y. So I'll write and z plus angle z plus angle y will be equals to 180 degree, because these two angles are forming linear pair here. So we'll write linear pair. Okay, so angle z we have calculated here. So value of angle z is 80 plus angle y equals to 180 degree, or hence angle y will be equals to angle y will be equals to 180 degree minus 80 equals to 100 degree. Okay, now we have got the value of all three angles. X is 100, y is 80, and z is 80 and y is again 100 degree. Okay, now moving to the next example, we have in a parallelogram RING ring, figure 3.28, if measure of angle R is equal to 70 degree. This M angle R is written as, we have this written M angle R. So we did this as measure of angle R equals to 70 degree. Okay, so we have to find all the other angles. So let's start its solution. We are given that in parallelogram every time you have to write this in which figure you are working. Like in this case we are given this parallelogram, so we'll write in parallelogram, then name of the parallelogram RING. Okay, in parallelogram RING ring, angle R is given which is 70 degree. Therefore its opposite angle, angle N, will be equals to angle R, and R is equals to 70 degree. That means N is also equals to 70 degree, and angle R plus angle I will be equals to 180 degree. Why? We have to write the region in every time. So here the region was opposite angles of parallelogram are equal, and here the region is adjacent angle of parallelogram are supplementary. Okay, the adjacent angle of a parallelogram are supplementary. Since we already know the value of angle R, which is 70 degree, plus angle I will be equals to 180 degree. Therefore angle I will be equals to 180 degree minus 70 will be equals to 110 degree. And so angle I is equals to 110 degree. Then we have to find the remaining angle, which is angle G. Now angle G will be equals to angle I equals to angle 110, because opposite angles of parallelogram are equal. So angle I is opposite to angle G, therefore the value of angle G will be equals to 180 degree. Okay, so that's the solution of the example number 5. Now moving to the next example, we have example number 6, which is if the figure 3 in figure 3.31 help is a parallelogram. Now we have this parallelogram HELP, help is a parallelogram, length are given in centimeter, given that OE is equals to 4, this length OE is equals to 4 and HL is 5, this HL is total 5 more than PE, this HL is 5 more than PE. We have to find the OH. Find करना है हमको this region OH. Okay, so let's start solution. What we are given is first we write in parallelogram. Every time you have to write name of the shape in which you are working. So write in parallelogram HELP. Okay, in parallelogram HELP we have OE is equals to 4, as it is given in all length are centimeters. So write 4 centimeter. Okay, now we have to find the OH. This one is given. We know that in parallelogram the diagonals bisect each other. So write therefore OP will be equals to OE, because these are the diagonal and they are bisecting each other. That means this part of the diagonal will be equals to this part. That means OP will be equals to OE, and OE is given, which is 4 centimeter. That means OP is equals to 4 centimeter. Hence the total length of the diagonal, which diagonal, PE, will be equals to 4 plus 4 equals to 8 centimeter. Okay, now as in the question it says HL, this diagonal HL is 5 more than PE. So right, so HL will be 5 plus PE, that is 5 plus PE is 8 equals to 13 centimeter. Okay, now we have got the value of HL and we have to find OH. So as these two diagonals are bisecting each other, that means the region this OH and OL will be equal. That means this OH will be half of HL. So right, hence this length OH will be half of HL. That means 1 by 2 into HL is 13 centimeter. So 1 by 2 multiplied by 13 centimeter will give us 6.5 centimeter. Hence OH is equal to 6.5 centimeter. So that's the solution of the example number 6. So with this we have finished all the examples before the exercise. Now let's start with the exercise 3.3. okay, in this figure we are given a parallelogram ABCD. Complete each statement along with the definition or the property used. Okay, so first one is we are given AD is equals to what? So let's write it answer. Number 1, part 1, we have AD equals to something. So we'll first locate the AD. AD is here. This length is AD. So AD is the side of a parallelogram ABCD, and we know that in a parallelogram opposite sides are equal. So therefore this AD will be equals to its opposite side, which is BC. So I'm writing it with a different color. Let's use blue. So its answer is BC. And as you are asked, write the definition of the property used. So property used here is opposite sides of a parallelogram are equal. So this is the property used in the part 1 of the question number 1. Moving ahead to the next part, we have angle DBC. The angle is angle DCB. So now we have to locate the angle DCB. This angle will be equals to its opposite angle DAB. As we know, in a parallelogram opposite angle are equal. So you are asked DCB will be equals to, answer will be angle DCB will be equals to angle DAB, and the reason for this one is opposite angles of a parallelogram are equal. Okay, moving to the next one, we have OC is equals to what? So first locate the OC. OC here is this length. This length is OC. So OC will be equals to its other length of this is this diagonal, which is AO, or you can say OA. So OC will be equals to OA. Region for this one is diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. That's why these two are equal. Last one is measure of angle DAB plus measure of angle CDA equals to what? So first locate the angles. Angle DAB, this angle, and angle CDA, this one. And there's some, as you can see now, these two angles are adjacent angle, and we know that adjacent angle of a parallelogram are supplementary, so its answer will be equals to 180 degree. And reason for this one is adjacent angles of parallelogram are supplementary. Okay, so that's the answer of the question number 1. Fill in the blanks. Okay, now moving to the next question. The question number 2 is, consider the following parallelogram, find the value of the unknown x, y and z. So we are given it here total 5 figures. We have to find the value of x, y, z in each of them. So we'll start with the first one. So let's try the answer number 2. Part 1, we have this figure. Let's draw the figure here. We have, I'm drawing it roughly, but in your notebook you will draw it neatly and properly with the help of pencil and scale. Okay, so these are given parallelogram, which is like this. It's named here A, B, C and D. Okay, the angle here is 100 degree. Then we have here x, y and z. Okay, and we have to find the value of x, y and z. So first we'll write the name of the figure, which is in parallelogram ABCD. Okay, in parallelogram ABCD, we know that in a parallelogram the adjacent angles are supplementary. That is, angle B plus angle C will be equals to 180 degree, right? And the region for this one is, so write the region, adjacent angles of a parallelogram are supplementary. So the region is adjacent angle of a parallelogram are supplementary. Therefore, angle B plus angle C will be equal to 180 degree. And we are given the value of angle B, which is 100 degree, plus angle C is given as x, will be equals to 180 degree, or x will be equals to 180 degree minus 100 degree equals to 80 degree. Okay, so now we got the value of angle x, which is 80 degree. So now we have, and we have angle C will be equals to angle A. Why? The reason for this one is opposite angles of a parallelogram are equal. So write opposite angles of parallelogram are equal. So angle C is x, which is we have already calculated as 80 degree, and angle A is Z. So Z is equals to 80 degree. Okay, then we have to find the value of angle y. So now we'll write, and angle A, or you can say it right, angle D plus angle A will be equals to 180 degree. Region for this one is again same like this first one here, that adjacent angles of a parallelogram are supplementary. Okay, therefore angle D we have y, angle A we have calculated, which is 80 degree equals to 180 degree, or angle y will be equals to 180 degree. Okay, so we have got the value of all three angle. Angle x is 80 degree, y is 100 degree, and angle z is 80 degree. Okay, moving ahead to the second part of the question. Let's write the part second. So first we'll draw the figure. The figure given to us is like this. Okay, the given figure is something like this. Okay, so angle here is 50 degree, here we have y, then x and z here. Now we have to again find the value of x, y and z. So I have drawn this figure roughly. You will draw this neatly and cleanly in your notebook. Okay, so let's start. In parallelogram, let's name it parallelogram ABCD. We'll start from here, A, B, C and D. Okay, so write in parallelogram A, B, C, D, the angle A plus angle D will be equals to 180 degree. Region is again same. The adjacent angle of a parallelogram are supplementary, which is adjacent angles of parallelogram are supplementary. Okay, angle A we have is given as x, and angle D is given, which is 50 degree equals to 180 degree, or x will be equals to 180 degree minus 50 degree, results into 180 minus 50 is 130 degree. So the value of x is 130 degree. So now, and angle C is equals to angle A, that is angle C is angle y, and A we have already calculated here, which is x equals to 130 degree. Region here is opposite angles of a parallelogram are equal. That's why angle C and angle A are equal, and angle y is turned out to be 130 degree. Okay, now we have next one is, and the opposite angle we have calculated here. So now in order to calculate this z, what we gonna do is, this z will be equals to the, this z is the exterior angle for this parallelogram ABCD. Okay, which is whose one arm AB is extended. Okay, so we got the exterior angle z. This z will be equals to angle A. So these two angles will be equal, since this side, these two sides are parallel. Okay, and this AB will be its transversal, so angle X or angle Y will be equal. So we'll write angle X will be equals to angle Z, or angle Z will be equals to angle X, and X we have calculated here, which is 130 degrees. So it will be equals to 130. Region for this one is corresponding angle of a parallelogram are, these are the corresponding angle of a parallelogram. So write corresponding angles of parallelogram are equal. That's why this z is equal to 130 degrees. So again we got the value of all three angles x, y and z here. Okay, moving to the next part, we have part 3. So let's draw the figure first. We have a figure like this. This is a figure given in the part 3 of the question number 2. Okay, so we have the angles. This one is 90 degree as it is given as perpendicular. We have angle x here, angle y and angle z here. The angle, this one is given as 30 degree. Okay, so let's first name this parallelogram as A, B, C and D. Okay, so now let's write in parallelogram ABCD, as this angle is given as 90 degree, so its vertically opposite angle x will also be equals to 90 degree. So therefore x will be equals to 90 degree. So right, reason is vertically opposite angle are equal. So these are the vertically opposite angle, as it is given already in the question that this is perpendicular. So this opposite angle x will be equals to 90 degrees. So we got the value of x. This angle is already given 30 degree. So now we come to the triangle. Let's name this point of intersection of the diagonal as O. So now in triangle COD, the sum of the angle C plus angle O plus angle D will be equals to 180 degree. This is the angle sum property of a triangle. Angle sum property of triangle. Okay, or we can write triangle. Okay, angle C it's given, which is 30 degree. Angle O we have calculated, which is x, that is 90 degree, and angle D is y, equals to 180 degree. So this 30 plus 90 will be 120. When you shift this 120 on the other side, will be minus 120. So the value of y is equals to 180 minus 120 is equals to 60 degree. So we got the value of y is 60 degree. Then we have to find the z. Now z will be equals to angle y equals to 60 degree. Reason for this one is they are alternate interior angle of a parallelogram. Therefore alternate interior angles of parallelogram are equal. So hence we got the value of all three. Y is 60, z is 60 and x is 90. Y and z are 60 degree each and x is of 90 degree. So that's the solution of the part 3 of the question number 2. Okay, so similarly we can solve the remaining two part of this question. So next two are, I'm giving you these two part as the homework. Okay, you will try them by yourself. If face difficulty, we'll discuss that in the next class. Okay, I'm explaining this question. So here also we have to find the value of x, y and z. As this angle is 80 degrees, so its opposite angle y will also be of 80 degree. Okay, since this one is 80 degree, so its adjacent angle x will be equals to 180 minus 80 equals to 100 degree. Okay, then you have to find the value of this z here. Since this x here is 100, so its opposite angle here will be also be of 100, and these two are forming linear pair. So this will be 180 minus 100 equals to 80 degree. Okay, so I have explained how we can solve this. You will write the solution by yourself. Similarly, in the next part, this angle is given 112, so its opposite angle y will also be 112 degree. Okay, then you will apply the angle sum property for this triangle. This is 112, this is 40, so 112 and 140 will be 152. When you subtract 152 from the 180, you will get the value of x, and that will be equals to value of z. Okay, so that's how you can solve the remaining two part of this question. You will try them yourself. Still, if you face any doubt or difficulty, we'll discuss that in the next class. Okay, with that we have completed the question number 2. Okay, so that's all for now. In next exercise we'll start with the question number, in next session we'll start with the question number 3. Okay, so that's all for this class. Thanks for joining here. Thank you.